Okay, hello everyone, and welcome back to my Scratch. And today we will try to solve some problems related to the acceleration, and I'll try to cover several problems related to equations of motion, graphs, and so on. So here I have the first problem. It says a car is traveling at 20 meters per second north on a level road. The driver applies the brakes and the car slows with a 4.0 meter per second squared south. What is the stopping distance of the car? So from this problem, I can have several information, and one of them is what is the initial velocity, which is 20 meters per second, and what is the final velocity, which is zero because it says it's stopped, and what is the acceleration is 4.0 meter per second squared. Now, what is needed is what is the stopping distance. So we need to know what is the distance d. So, as you guys remember, we talked about three equations of motion, which you should know, like V final equal to V initial plus AT, D equals to V initial t plus half AT squared, and V final squared equal to the V initial squared plus 2AD. So I found it's more convenient to use the last equation because I don't have time in my in the information given in the problem. So all I have to do is just to put the final velocity equals to a 0. The initial velocity is 20 and 20 squared means 400. Then I have 2, I have a for the acceleration, 4 meter per second squared, and then I have d. But you have to be careful, you must use a negative sign here. And why is that? Because the car was initially traveling towards the north. When you apply the brakes, the car slows down but towards the south. So because here you have north and here you have south, then you must use a negative sign and you do the calculations, then d equals to 50 meters, which is the answer A here. Now we can move on to the second problem, and it says that the graph below shows a velocity versus time graph of a particle moving along the x-axis. At time t equals to 0, assume that x equals to 0 meters. What is the particle's position at t equals to 3 seconds? Okay, so now these graphs are very famous, like we see them a lot in questions. And in this graph, you can see the y-axis is the velocity and the x-axis is the time. And what they want us to find is what is the particle position at 3 seconds. Now, if you guys remember, we've mentioned before that velocity equals to distance divided by the time. So the distance must equal to the velocity multiplied by the time. So here we have we want to find the distance, so I should find the velocity multiplied by the time. Now, if you have a velocity time graph and you want to find the distance, you must find the area under the graph. And how I do this? Now look at this graph. I have this line, I have that line. So what I will do is I will try to split it into different areas. So for example, here I have the area A, which is a square, the area B, which is another smaller square, and the area C, which is a triangle. So if I can find the area A plus the area B plus the area C, that will give me the distance, the distance which is the area under the graph from 0 to 3. So this is the rule. Whenever you have velocity time graph and you want to find the displacement or the distance, then try to find the area under the graph. So let's first find the area A. The area A is a square, or a rectangle, so it must be the length times the width, which is 2 times 4, that will be 8. For the area B, I have from 3 to 2, that is 1 times 2, so it is 2. So the area under B is 2. Now what about the area C? We know that the area of a rectangle is half the base times the height. Now the length of the base is 1 and the height is 2, so it's a 1 times 1 times 2, that gives me 1. So now I have three areas. I have 8, I have 2, I have 1. Then add them together, it gives you the total area under the graph, which is 11 meters. Okay, now the next problem says that a speeder passes a parked police car at 30 meters per second. The police car starts from rest with a uniform acceleration of 2.44 meter per second squared. How much time passes before the speeder is overtaken by the police car? Now we have in this problem we have two cars. One of them is a speeder who is moving at a constant speed of 30 meters per second, and the police car which is accelerating from 0 up to a certain speed at this acceleration 2.44 meter per second squared. So, in order for the police car to catch the speeder, they must both cover the same distance. So, what I will do first is I will find the distance covered by the car. And we know again that velocity equals to distance divided by the time. So, the distance equals to the velocity multiplied by the time. Now, the velocity is 30 meters per second and the time is unknown. Now, I will find the distance covered by the police. And to find the distance, it should equal to v initial t plus half a t squared. Now, the police started from 0, then he accelerates with an acceleration of 2.44 meter per second squared. So it's a half times 2.44 times t squared. Now, in order for the police to catch the car, then these two distances must equal to each other. So d1 must equals to d2. That means that 30t equals to half multiplied by 2.44 times t squared. Now, I need to solve this equation. So I get half times 2.44t squared minus 30t equals to 0. If I take t as a common factor, then I end up with two solutions of this equation. It's either t equal to 0 or t equals to 24.6 seconds. So now I have two times. The first time t equals to 0 is when the speeder passed and met the police car at the beginning, and the second time is when the police car caught the speeder. So this is what we need, 24.6, which is given as in the answer A. So now let's move on to the next problem, which is the problem number 4, and this is about a projectile motion. It says that, as shown in the figure below, a projectile is fired horizontally with a speed of 30 meters per second from the top of a cliff 80 meters high. With what speed will it strike the level ground at the base of the cliff? So here I have a cliff. This is an 80 meters high cliff, and we throw a projectile horizontally at 30 meters per second. When they tell us it's horizontally, it means that the horizontal velocity is 30 meters per second, but the vertical velocity is 0. So if I want to find how long will it take the projectile to hit the ground, I must know what is the vertical velocity, or I must use the vertical velocity. The first thing we will do is we use this equation that says d equals to v initial t plus half gt squared. Now here I have to use g because it's a vertical motion, so so the acceleration will be the acceleration due to gravity. Now I will put the height equals to at the initial velocity is 0 plus half times 9.8 times t squared. Now I can solve for the time, which is 4.04 seconds. Now we know how long does it take for the projectile to hit the ground. Now I need to know what is the final vertical velocity. So V final equals to V initial plus GT. Again, once the V initial is 0 and G is 9.8 and the time is 4.04. Now we know what is the final velocity, which is 39.59. Now we want to read the question carefully. It says, with what speed will it strike the level ground? So it did not ask us with what vertical speed, it asked us with what speed. So in this case, I have to consider both speeds, the vertical and the horizontal. So if I want to know what is the total speed, I have to use this equation which says the square root of Vx squared plus Vy squared. Now the Vx squared is the horizontal velocity and the Vy squared is the vertical velocity. So the horizontal velocity is 30 squared plus 39.59 squared, then it gives me 49.67 meter per second, which is about 50 meter per second, which is A. Now the next question says that a ballast bag is dropped from a balloon that is 200 meters above the ground and rising at 10 meters per second. For the bag, what is the maximum height reached above the ground? So in this problem, we have a bag that is attached to a balloon and is dropped from the balloon. Now, if you think about this problem, if we assume that the balloon is stationary or not moving, in this case, the initial velocity of the bag would be 0. But because the balloon is moving up at 10 meters per second, then I have to take this as the initial velocity up. So if you want to know what is the maximum height, then we need to use this equation that says V final squared equals to V initial squared plus 2GD. Now for the maximum height, we know that the final velocity would equal to 0, and here I have the initial velocity equals to 10 squared, which is 100, and because this balloon is moving up, then I will use negative 2 times 9.8 multiplied by d. In this case, I can solve for d, which would be 5.10 meters. But remember that the balloon was initially at 200 meters. So if I want to know what is the maximum height, then I must add 200 plus 5.10 meters. That gives me 205 meters. Now let's move on to the next question, and it asks about another graph. And it says that a car starts from a position of 4.0 meters east of a school at a velocity of 20 meters per second east and moves as shown in the following velocity graph. What is the car's position relative to the school at time 6.0 seconds? So as you can see here, we have the velocity time graph, and we have the time here, and we want to know what is the car's position relative to the school at time 6 seconds. So this is 6 seconds. So as I just mentioned in the other graphs problem that if you have a velocity time graph and you want to find the position, you must find the area under the graph. So now I have two areas. This is the first area and this is the second area. Now I need to find the first area, which is 5 times 20. Don't forget this is a triangle, so it must be half base times the height. So it's a half times 5 times 20, that would be 50 meters squared, which is the distance. Of course, this is the area, but the distance covered will be 50 meters. Now, for the other triangle, which is B, I have the length of the base is 1 and the length of the height is -4. So the area would be half times 1 times -4, that would be -2 meters. So what is the total displacement here? 50 minus 2, that will be 48 meters. But remember that the car did not start from 0. It started from a position of 4. So I must add 4 plus 48. So the start, so the final position would be 52 meters from the start. Okay, now let's move on to another projectile motion problem, and it says that three balls are thrown off a cliff with the same initial velocity v0. Ball F is thrown upward, ball G is thrown horizontally, and ball H is thrown downward as in the figure below. Which of the following is correct about their speeds at the moment they reach the ground? So let's first think about the first ball, which is thrown up, and the second ball, which is thrown down. If you think about it, the ball that will be thrown up, it will move all the way to the highest point, then the velocity reaches 0, then it moves back down, and it will have the same initial velocity that it was thrown with. Now, of course, we assume here that there is no air resistance, so it means that the ball that is thrown down and the ball that is thrown up at this point will have the same velocity, so they must reach the ground exactly as they reach the ground, because they will be both accelerated exactly the same way with the acceleration due to gravity. So what about the other ball, which is thrown horizontally? Now remember that this ball is thrown horizontally, but it does not have any vertical velocity. So it means that the vertical velocity is 0. So if I want to find what is the velocity as it reaches the ground, it would be just its horizontal velocity, because uh, because because this ball will have a horizontal velocity, but not a vertical velocity. Um, uh, so so here the I no okay so no I don't think this is correct. So I need to I need to say this one more time. For the third ball, it has a horizontal velocity and it has a 0 vertical velocity. So by the time it reaches the ground, the horizontal velocity will stay the same, but the vertical velocity will increase, and it becomes and it becomes equal, and it becomes equal to the velocity of the, or the initial velocity of these the ball that was thrown down and thrown up. So when it reaches the ground, the horizontal ball, it will have a total velocity of the square root of the vertical velocity and the horizontal velocity. Okay, so I don't want to confuse you here, so I will try to repeat my answer here. So for the first ball, it was thrown down. Let's say that it was thrown down with let's say 2 meters per second, any number, right? Now, for the ball that was thrown up, it was also thrown up with 2 meters per second, but it will slow down, it becomes zero, then it speeds up again, and at this point it will have the same velocity of 2 meters per second. So now both of them will be moving with 2 meters per second, so they will both reach here with the same velocity. Now, what about this ball? Now, this ball is thrown horizontally with 2 meters per second, but vertically with 0. So, as this ball moves down, then the vertical velocity will increase, right? It will keep increasing, and the horizontal velocity will stay the same. So at the end, the total velocity will be the square root of the horizontal plus the vertical, which would be the same as this velocity and that one. Okay, now let's move on to the next problem, which it says that a ball thrown vertically upward at 19.6 meter per second for its complete trip up and down, or up and back down to the starting position, its average speed is what? So if you want to find the average speed, it's the total distance divided by the total time. So I need to use this equation that says V final equal to V initial plus GT. Now, when the ball moves all the way up, then the final velocity is 0. The initial velocity is 19.6 minus, because it's moving against the gravity, 9.8 times t. So it takes 2 seconds. So now I can calculate the distance up, which is calculated by V final squared equal to V initial squared plus 2GD. Remember, the final velocity is 0, and the initial velocity is 19.6 squared minus 2 times 9.8 multiplied by the distance. Now I can solve for the distance, which is 19.6 meters. For the ball to move all the way up, it must cover 19.6 meters in 2 seconds. Now, remember, the ball is moving up, then it moves down again. So it becomes 19.6 meters plus 19.6 meters divided by the total time, which is 4 seconds. So that gives me the average speed, which is 9.8 meter per second. The next problem says that a parachutist jumps out of an airplane and accelerates with a gravity to a maximum velocity of 58.8 meters per second in 6 seconds. He then pulls the parachute cord, and after a 4.0 second constant deceleration, descends at 10 meters per second for 60 seconds, reaching the ground. From what height did the parachutist jump? So here in this problem, we need to find the total distance, or the total height that he jumped from. So to solve this problem, you need to divide it into three parts. For the first part, you calculate the distance when he was accelerating down. So his final velocity equal to his squared equal to initial velocity squared plus 2GD. Now the initial velocity was 0, and the final velocity was 58.8, and g is 9.8. So now I can calculate the distance for the first part, which is 176.4 meters. Then for the second part, I can also calculate the distance, but I first need to calculate the acceleration. So here I use the equation that says that d equals to v initial t plus half a t squared. Now the v initial is 58.8 because I have to use the final velocity he reached at the first part, multiply by the time that he spent. From the problem it says 4 seconds. Now in this case he was decelerating because he opened the parachute, so I have to use negative sign, half times the acceleration. Now how to find this acceleration? Now to find the acceleration, I need to go back to the problem, and it says that the parachutist descends at 10 meters per second for 60 seconds. So this 10 meters per second will be his final velocity, and the 58.8 will be his initial velocity plus 8 times 4. That gives me the acceleration. Now I have to use it here and find the distance for the second part, which is 137.4 meters. Then for the third part, he was moving at a constant velocity. So I just need to apply velocity equal to distance over time. So the distance equal to the velocity multiplied by the time. So the velocity is 60 meters per second. Sorry, the time is 60 seconds, and the time is the time is 60 seconds, and the velocity is 10 meters per second. So it becomes 600. So now I have three parts: the distance for the first part, the distance for the second part, and the distance for the third part. So we add them together and we get the total distance, which is 913.8. Okay, so we'll just stop here and I'll see you in the next video very soon, inshallah. Thank you.